it's homework time. Yes, let's do it. All right, let's start by jotting our name down at top of the paper. I'll write my name and you write yours. And then we'll also record today's date. All right, today you write the actual date, where and when you are in this wonderful world of ours. Our instructions: draw a tape diagram to model each comparison. Use greater than, less than, or equal to compare. So this is a big fourth grade thing here, comparing fractions. You notice we've done a lot on this, and there's more to come. So learn to love it, y'all. All right, so looking at this first one, in fact, look at these two together. Notice that this one, it's 2 3/4, 2 7/8. And over here we have 10 2/6, 10 1/3. What we can do with this, right? Think of this as pi. So here we have 2 whole pies and 3/4 of another, and then we're comparing that with 2 whole pies and 7/8 of another. Really, those 2 whole pies and the 2 whole pies that we're comparing, we could just set those aside because we know they're equal. Really what we're comparing here in both A and B are the fractional components. We're just looking at the fractions to make this comparison because we know that 2 equals 2 and 10 equals 10, so we could set those aside. So when we draw the tape diagram, you'll be relieved to know we don't need to draw 2 3/4 or 2 7/8, 10 2/6, 10 1/3. We can just draw the fractional part. So for example here, and I'll go ahead and let me switch up here and do rectangles for, and you want to make them both about the same size. So best you can, best I can, best we both can. So this is going to be 3/4, and this one will represent 7/8. All right, so if I take this, I know I can split it in half and then split each half in half, and that will give me fourths. Yeah, they're not perfect, but hey, neither am I, neither are you. Nah. All right, and so now on the next one, so there's 3/4 shaded in, and this is 7/8. You're going to find this is actually kind of not that challenging. So I could start by drawing fourths, right? And then if I bisect fourths, I end up with eighths, right? Aha, there we are. And even with the imperfection of my drawing, I can easily see what? That 7/8 is more than 3/4. 3/4 is less than 7/8. And in fact, I can even go, let me switch up colors here, and if you have another color handy, you can do the same. I can even make little dashed lines here. And that will tell me that 3/4 equals what? And I'm going to continue in red here for this. 1, 2, 3, 4, 5, 6 eighths. See, so mathematically I can confirm that. So if you're drawing, and the reason I'm showing you that is if your drawing is not all entirely conclusive, you can do the math end of it as well, and that shows you that yes, indeed, 7/8 is more than 6/8. 3/4 is less than 7/8. So that means 2 and, to go back to the original example, 2 3/4 is indeed less than 2 7/8. Same thing over here. Let's draw 2 tape diagrams of approximately the same size and shape, best we can. All right, and then this one will be actually I'm gonna well, all right, I'll do 2 6 here, 1/3 below, so we don't confuse ourselves. But I'm gonna draw the 1/3 first, and you'll see why. Okay, so if I draw 2 lines, I have thirds. Shade in one of them, that's 1/3, right? And here's why, because if I duplicate that up top to make 6, I draw the thirds, you got it, and then bisect those thirds, I have 6. Okay, now the drawing seems to indicate, hey, that these are equal, right? But again, I'm going to switch colors, and just to demonstrate, if I decompose these thirds into 6, that confirms for me that, look, 1, 2, 6. Okay. So that they indeed mathematically I can see as well as from the drawing, because our drawings aren't perfect, so it's good to confirm it mathematically. That indeed these are equal, and again, we're returning to the original example, 10 and 2/6, 10 and 1/3, although it's only the fractional component that we really need to compare. Whew, yeah, let's move on. All right, and you can see we're looking at C and D from number 1, more of the same, and then we have with number 2, we'll be drawing area models. So let's do C and D first. So again, we have 5 and 5 for the whole number, 2 and, all right, we're going to have to come back and do that. But here, so 5 and 5, we know we can just draw the fractions because the whole numbers are equal, so we don't really have to compare them. They're the same. And so I'll draw 2 rectangles of approximately same size and shape. This one will be 3/8. That's a 3 really. And this one will be 1/4. And I'm going to partition up the fourths first and then do the eighths. You know why, right? Okay, so fourths are easy to do. Great. And then if I'll shade in the 1/4. And then if I duplicate that up here, draw the fourths first. We've done plenty of this already, so you know what I'm going at. And then I can bisect the fourths to make eighths. And how many? 1, 2, 3. Now 3/8 certainly looks like more, but let me go ahead and just be certain of it. If I were to convert this to eighths, how many eighths is 1/4? 1, 2, right? So 2/8. And we know how to do that mathematically, right? 1/4 times 2/2. We've done plenty of this already with equivalent fractions. You see how it all intersects, so to speak? So we can see that 3/8 is plainly more than 2/8, which means that 5 and 3/8 is, yes, greater than 5 and 1/4. Over here, it looks like we need to do something first. Okay, I think it makes sense to convert this to a mixed number. There's a couple ways we can do this. We've done this before, and it's not strictly a Eureka thing, but it is a strictly mathematical thing, which is that a fraction expresses division. So this is saying 21 divided by 3. What's 21 divided by 3, y'all? That's right, it's 7. So this equals 7. So now, I know they're telling us to draw a tape diagram, but I don't know. Gosh, I'm a teacher and I'm saying to you, hey, it's kind of pointless to draw a tape diagram here to compare 2 and a fraction to 7. Like, we know that 2 and 5/9 is less than 7. I mean, if you, I'm not drawing a tape diagram. You could do this and maybe your teacher will accept it. It's like, no tape diagram needed. I mean, like, we know 7 is greater than 2. All right, come on, we're not going to play silly. All right, and number 2, we're to make area models to make like units and then compare. And again, we're starting here. We have 2 and 4/5, great, but then we have an improper fraction here. So let's use some magic here. We'll do this one the Eureka way and decompose it. So 4/4 is 1, right? So I could do this a couple of different ways. I'll break it down into little bits for you. So there's 4/4. Can I make another 4/4, another 1 whole? I sure can. Yep, 4/4. So that's 8 of those 11/4. And then, yes, I still have another 3/4, right? 4, 4, and 3 make 11. So that is, all together, I have 1 whole, 2 wholes, and then 3/4. So I can see as before, I'm comparing 2 wholes with 2 wholes. So really I could just look at the fractions. I can look at 4/5 compared to 3/4. So we're doing area models now. So this is a little different. So over here I'm going to draw 4/5, and then over here I'll draw 3/4 and make these about the same size. So once again, this will be 4/5, and this will be 3/4 because I know I have 2 wholes. Oh my goodness, problems this morning. All right. So I believe the way we were doing it before was drawing vertical lines on the first model and then horizontal lines on the other, and then overlaying them basically. So to make fifths here, all right, I'm going to draw 4 equally spaced lines, 1, 2, 3, and 4. And now we're talking about 4/5, so I'm just going to do my quick little scribble scrabble here. 4 out of the 5. And over here we're looking at 3/4, so I'm going to go horizontally with the lines. 1, 2, 3 lines will do it, splitting the halves in half as we always do. And so that's 3 out of 4. And then in this case, our least common multiple is, right, 20. So I can overlay, and I'm going to switch colors, and if you like using colored pencils the way I do, then you might want to do the same. What I'm going to do is, over here on the fifths, I'm going to overlay the fourths. So I look at the lines I made for fourths, right? And then over here, I'm going to overlay the lines I made for fifths. So I'm going to draw 4 vertical lines. So 1, 2, 3, 4. And I'll keep the same color. I'll write it over on the right side. So now this is 4, 8, 12, 16 out of 20. That's 16 twentieths. And this is 5, 10, 15 out of 20. Really, isn't this exactly what we did with equivalent fractions? Say yes, because it is. And so, let me get back in black here. So now really we're comparing 2 and 16 twentieths to 2 and 15 twentieths. Obviously 16 twentieths is more than 15 twentieths. So 2 and 4/5 is greater than 11/4, to return to numbers we were originally given. See, a bit of work there. This one here, I'm going to do the work up above here, so good thing I was able to spare that space. Again, now this one's a bit easier because we're dealing with the whole number 2 in both cases. We don't have to do a conversion first. So really we're comparing 3/5 and 2/3. So if I draw 2 area models, rectangles of approximately the same size and shape, boom. All right, and so now here I'm going to make 3/5, and I'm going to do the vertical lines, draw 4 vertical lines to make fifths. 1, 2, 3, 4 lines makes fifths, and I will shade in 3 of those in my usual scribble scrabble way. And then over here I'm looking at thirds. So I just need 2 lines to make 3 partitions, and I'm doing 2/3, so I will scribble scrabble in 2 of the 3. So this is 3/5, and this here is 2/3. And again, the least common multiple between 5 and 3. If you skip count by 5s, in other words, what's the first number you come across that is also a multiple of 3? 5 is not a multiple of 3. 10, not a multiple of 3. 15, that is. And also, in this case, happens to be 5 times 3. So I'm going to switch colors now and overlay the thirds on the fifths and the fifths on the thirds. So I made these 2 horizontal lines for thirds, and I will overlay them here. And that gives us 3, 6, 9 out of 15. So this is 9/15. And then over here I'm going to overlay the 4 vertical lines to make fifths. So 1, 2, 3, and 4. And that gives me 5, 10 out of 15. This is 10/15. And now I can see what? Which is greater, less than, equal. Okay, so 2 and 3/5 is 2 and 9/15. 2 and 2/3 is 2 and 10/15. 9/15 is less than 10/15. That means that 2 and 3/5 is less than 2 and 2/3, and that's what the model shows. Whew, I hope it gets easier from this point. That was rigorous. Let's move on. All right, and as been often happening lately in these homework times, That last example is a whole bunch of practice. So we're just doing comparison of fractions, which again is a big fourth grade thing. Don't skip over this, like you need this one. And we can, but here's the beautiful part, we can use any strategy we want. And of course, you and I both want to use the simplest strategy. So for example, when we look at this first one, in fact, look at the selection we have here. A, B, C, and D have something in common that's going to make them easier to deal with. They all have the same whole numbers. So we can basically discount those whole numbers, set aside those whole pies, because we know 6 and 6 pies are equal, 7 and 7, 3 and 3, 2 and 2. We can just set those aside and compare the fractions to find the larger mixed number. Okay, so let's do that. So here we're looking at 1/2 compared to 3/8. So if you were to skip count by eighths and find which one is also a multiple of 2, you'd start at 8 and say, hey, 8's a multiple of 2. So that means I only need to change the 1/2, convert it to eighths, and then I'll have them both in eighths, and my comparison will be very accurate. Are there other strategies we could use? Yes. I mean, I could say that 3/8 is, we'll do this. We'll say 3/8 is less than 1/2, right? We know that because 4/8 equals 1/2. Or I could take the 1/2, and this is where I was going at the start, and say, okay, if I convert that to eighths, it's going to give me a definite number. It's a factor of 2 times what is 8? 4, right? So 1/2 times 4/4, well, that's eighths. That's what I was going for. And 1 times 4 is 4. And so I can see that 4 is more than 3. 6 and 4/8 is more than 6 and 3/8. 6 and 1/2, therefore, is greater than 6 and 3/8. And let me tell you, if your teacher is anything like me, you need to have some kind of math here that shows how you determine this. Do not just go through this page and write greater than, less than, equal to on all of these. Because any teacher, I think, is going to look at that and say, oh, how did you get this? Okay, now comparing to a benchmark is what we did here in A. It's not going to work here so much in B, although we could. Because we have 5, 6, and 11/12. Both of those are pretty close to 8, all right? There is a reasoning we could use there, but I find it a little convoluted. So I'm going to go ahead and say, all right, well, I'm going to instead convert 5, 6. I know I'm going to multiply that some value of 1 to get 12ths. Well, that's a factor of what? So 6 times what is 12? 2, of course. So we're going to multiply 5, 6 by 2/2. That will give us a numerator of 5 times 2 is 10, and we see that 7 and 10/12 is obviously less than 7 and 11/12, so therefore 7 and 5/6 is less than 7 and 11/12. All right, so let's go on here. Again here, this one's going to work easy with the conversion. We're looking at 6/10 and 2/5. Now we could compare that to the benchmark of 1/2. We could do it that way. I like the conversions though. So we're going to look at 2/5. We can put that into tenths, right? And that will give us a nice simple comparison. What's the factor here? 5 times what is 10? 2. So we're going to multiply 2/5 times 2/2, which gives us what in the numerator? 2 times 2 is 4, right? So 4/10. So 3 and 2/5 equals 3 and 4/10, which we're comparing to 3 and 6/10, yes, which is clearly greater than. And this math shows here how you got your answer. So, and here again, we're looking at fifths and 15ths that we're comparing. So I can see that, hey, I can multiply fifths to get 15ths, and I only have to change one of the numbers. So what's the factor here? 5 times what is 15? Right, 3. So 2/5 times 3/3 is how many 15ths? Well, 2 times 3 is 6. So now I'm comparing 2 and 6/15ths to 2 and 8/15ths. I could see that 6/15ths is less. Therefore, 2 and 2/5 is less than 2 and 8/15ths. Now, in these, yes, notice what we have going on in E and F. We have thirds and fourths, fourths and thirds. How interesting. Okay, so now think about it. If you take that cake and you slice it into thirds, or you take that same cake and you slice it into fourths, we can see that thirds are bigger pieces. So we can say here simply that thirds are greater than fourths. So 10 bigger pieces compared to 10 smaller pieces, 10 bigger pieces, 10 smaller pieces, 10 thirds, 10 fourths. Obviously 10 bigger pieces is more than 10 smaller pieces. Now let's see if that logic will work here as well. So we know again that thirds are bigger than fourths, but oh, look what they did to us. You see that? Now we have 12 of the smaller pieces, so we can't quite so easily say that because here we had 10 pieces of each. Okay, but what we can do here, we can use the idea that fractions express division. So what is 12 divided by 4? Yes, it's 3. So this one equals 3, and 10 divided by 3, well, 3 times 3 is 9, and there's going to be a remainder. So this is greater than 3, right? This is going to be 3 and change, 3 and a third to be exact, right? So this one is equal to 3. This is greater than 3. Equal to 3, greater than 3. So this is 12 fourths is less than 10 thirds because this 12 fourths is 3, 10 thirds is greater than 3. All right, just a little bit to finish up here to round out this homework time. Let's get her done. Okay, as you'd expect, they get a little trickier here towards the end. You just take a quick look. You see we're dealing, here we're improper fraction and a mixed number. Improper fraction, mixed number, improper fraction, mixed number. And then here, this one it returns to a little bit more normalcy where we're dealing with two mixed numbers with the same whole number. Okay, but actually this one's going to require a little bit of math too. So, all right, let's start here. I like to approach this, I think, using the hey, fractions express division and do 38 divided by 9. So let's actually write that out. And that'll give us a sense of this number. So that's going to be, well, 9 times what is close to 38 without going over? Okay, 9 times 4 is 36. You subtract and we have 2, which, by the way we do 4th grade division, would be a remainder of 2. But because we're talking about ninths, it's actually 2 ninths. So 38 ninths equals 4 and 2 ninths. Now we could also have done that with the decomposition method. I just kind of like doing division. Now here's what's going to make this easier for us is that here it's 2 twelfths. And remember from that last one we did, if you cut that cake into more slices, the slices get smaller. That means ninths are greater than twelfths. And I know that's like opposite day kind of thinking, but it is so that ninths are greater than twelfths. So if you have 4 and 2 bigger pieces, 4 and 2 smaller pieces, obviously the 2 bigger pieces is more than the 2 smaller pieces. Therefore, 38 ninths is, yes, greater than 4 and 2 twelfths because ninths are larger than twelfths, and we have 2 ninths compared to 2 twelfths. All right, yeah. Let's do it on this one as well. Let's start off with that whole division way, and we could decompose it as well. In fact, I'll do that for you. We could do, well, how many fourths can we pull out of here? 4, 8, 12, 16, 20. We could pull out 20 fourths, which again is 4, 8, 12, 16, 20. That's equal to 5 wholes. And then we have how many fourths still? We have 3 fourths, right? So this would be 5 and 3 fourths, which we're comparing to 5 and 2 thirds. So how do you want to compare these? Well, there's a couple ways we can do it. We could say that, okay, they're both one slice of cake away from a whole cake, right? One more third, one more fourth would give us the whole cake. And because thirds are larger than fourths, this is a smaller number. So 5 and 3 fourths is the larger one. Or we could draw a tape diagram, which I think is going to make it more readily apparent to you than the logic I just explained, which is how we did it on some earlier lessons. All right, but let's draw it out here. So let's draw 3/4. It's easy to do, right? Drawing this tape diagram, I know you groan when I say let's draw a tape diagram, but it really just takes a couple seconds and makes it very clear to you. Might as well do something right if you're going to do it, right? And then you draw 2/3. And you could see it's not a huge difference, but no matter how shoddily you draw this, 2/3 is clearly less than 3/4. So 5 3/4 compared to 5 2/3. You see the 5 3/4 is more. So 23/4 is greater than 5 2/3. Same dealio here. We'll decompose this. We'll do it the Eureka way. So 8, 16, 24. Can't go to 32. So I could pull out, decompose 24/8, which leaves how many? Right? Another 6/8. So 24/8 is 8, 16, 24. That's equal to 3 wholes with the 6/8. Now I'm comparing that to 3 7/12. Okay, so let's look at this. A couple ways we could do this. We can compare it to the benchmark 1/2. They're both more than a half, right? Because this would be 4/8 is a half and 6/12 is a half. But this is just a 1/12 over a half. So 7/12 is a little more than a half, whereas 6/8 is more greater than 1/2, because it's 2/8 more as opposed to 1/12 more. So that is a perfectly logical way of comparing these. We could also see what I was avoiding is doing a common denominator, because we'd have to either simplify this and go to 12ths, or then we could go to 24ths on both of these and compare. So I don't know, we'll do that. Hey, look, we could do the math in our heads. What would 6/8 be in 24ths? Because that would be our least common denominator. 6/8 times 3/3 would give us 24ths, right? So that's 6 times 3 is 18, and 8 times 3 is 24, and this would be times, so 3 7/12 in 24ths would be 3. Well, we're going to multiply the 12 times 2 to get 24, so 7 times 2 is 14. That also confirms for us, if we were to find a common denominator, that yes, indeed, 6/8 is more than 7/12. All right, last one. Is your head spinning? All right, good. It's not just me. All right, so 10 3/4 compared to 10 4/6. All right, there's a couple ways we could do this, and this is what I was hedging towards on this last one here. I noticed that 4/6, that I can do something with that 4/6. I can divide it by 2/2, right? So 4 divided by 2 is 2, and 6 divided by 2 is 3. Didn't we just do one like this? Didn't we just compare 3/4 and find that it's more than 2/3? We did. Look, 10 3/4, 10 2/3, and here we did 5 3/4, 5 2/3. And so that's all we need to do. We can, just like if you want to draw an arrow up here with an exclamation point saying, ha, it's the same thing. So we know 10 3/4 is more than 10 2/3. We can look at our drawing right here, to our tape diagram, to confirm that. So this is indeed greater than. There's other ways we could do that. You could, we could have simplified and then use, or without simplifying, we could use 12 as a common denominator and calculate it mathematically. Other things. We could run an area model for any of these, but that's kind of the most laborious way. So, hey, we did it. That's what it comes down to. You've completed yet another homework time. Congratulations to the both of us, and I'll see you again next time. It is, once again, homework time.